So chapter 2, lesson 6, this is part 2, day 2. So we're taking a look here at the second objective now, writing step graph and absolute value functions. Okay, so let's take a look. So what's a step function? Okay, so think about steps. So they kind of make line segments here that make little steps, like a staircase. They can go up, they can go down. Um, so here's kind of an example. Says one psychologist charges for counseling sessions at a rate of $85 per hour, or any fraction thereof. So draw a graph that represents this situation. So if I think about this as a table here, so X is my hours, okay? So if I sit in there for half an hour, so half an hour, what's my rate? $85. If I sit in there for 1 hour, what's my rate? $85. But what if I sit in there for 1 hour and a quarter, hour and 15 minutes? Well, what's my rate? Well, 85 and 85, 170. What if I sit in there for an hour and a half? Again, still 170. And what if I sit in there for 2 hours? Still 170. So you can see it just makes jumps in increments of $85 basically. So any hour is 85, 2 hours would be 170, and so on. Anything in between 1 and 2 moves to that higher value in this case. Okay, so let's take a look at our graph then. So you can kind of just label these how you need to, and if you want to, you can put like a little graph break in there, and we're going to basically start here then at 85, and then every other line, so this is going to be my 170, so then 255. And I'm just making it easy on myself. I'm going in increments of 85 for every 2 blocks. And again, you can kind of, when you're making your graphs, you can kind of set your scale that you want to use. And 425. Now, this going up the side, this is our cost, right? It's our money. It's how much it's going to cost us. Down across the bottom then is going to be our time in hours. And again, I'm going to skip a block for every one. So half hour, 1, 1.5, 2, 2.5, 3, and so on. And so we can see from 1 minute up until that full hour is $85 it's going to cost me. Now, what if I was in there for 0? Would that be included? Well, 0, if I'm not in there, I don't have to pay anything, hopefully. So this ends up being an open circle here at 0. I'm going to switch my colors so you can see it a little better here. So we have an open circle here at 0. For 1 hour is included, and everything in between. Any minute in between 0 and 1 is $85. At 1 hour is $85. Okay? Now, what if I go 1 hour and 1 minute? Is it still $85? Nope. Now it jumps to the next $85, right? So now at 1 hour is kind of the starting point, but it's not included because $85 is included down here at the 1 hour. All the way up into 2 hours. And I can connect those. You can see my jump here, my step. Same thing then for 3 hours. 3 hours max is 255. Well, that's 3 hours is the same 255 all the way back until it gets to 2 hours. 2 hours is not included in that 255 price. And then we can go to 4 hours. So 4 hours is $340. And again, all the way back to that 255 price So 3 to 4 hours. And then we can do 5 hours. So 5 hours is at 425. And again, it makes it nice if I pick a good scale, because you can kind of see it just makes it easier for me to figure out what comes next. And then you can see I have these steps. Okay, so if I wanted to, it's almost like I'm walking up those staircase. Okay, now, is this a function or not? Well, this is. And how do we know? Well, we can use this vertical line test. So if I take this vertical line and I put it over this graph, remember, it can only touch the graph at more than only one spot at a time. So when I look over this graph, but then you can say, well, right there, what about that, Mr. Felton? It's touching the graph twice. Well, it's not really, because 340 is included at 4 because it's a solid circle. But 425 is not included at 4. It's just a holder. It's just a place, kind of a stopper, showing you it gets all the way up into that point, but it's not included at 4. Okay, so really when you have an open and a closed circle there, those aren't included. So you can kind of see all these open and closed circles kind of match up and make so that this is not, that they're not touching in more than one spot at any given time. So this is a function. So let's take a look at our second example then. So a recycling company pays $5 for every full box of newspaper. They do not give any money for partial boxes. Draw a graph that shows the amount of money, PX, for the number of boxes X brought to the recycling center. Okay, so $5 for every full box. So again, we can put our boxes down below. I'm going to move this graph over maybe. Nope. So again, we have our money coming up the side here. Squeeze that in there. And our boxes are down below. Again, I'm going to skip a line for every box. So 1 box, 2 boxes, 3 boxes, 4 boxes, and 5 boxes of newspaper there. And going up the side then, I'm going to go by 5s for every two lines. So keeping that at 0. So then 5, skip a line, 10, skip a line, 15, 20, 25. Okay. So now, this one's a little different than the last one, because again, we got to think about it. What if I bring in half a box? If I bring in half a box, do I get any money? Nope, I get nothing. $0. So the only time I get money, first chance I get money is at 1 box. I get $5. So at 1 box I get $5. So that's my solid dot. Now what if I bring in a box and a half? Still only $5, right? But if I bring in 2 boxes, now I have 2 full boxes, which means I should get $10, right? So all the way up until 2 is included in that $5 price, but 2 is not included, so that's my open circle there. So closed circle at 1 here, all the way up to 2. Now at 2, my price increases up to 10, so now I have a solid circle here at 10, and it stays the same all the way up to 3, so I have an open circle then here at 3. At 3, I get another $5, so I go up to $15, open circle here now at 4. Because at 4, my price jumps again to $20 and open to 5. And then again at 5 is 25, and it kind of runs out my graph. Okay, so you can see here my solid dot is on that other side. But again, if I look at this function wise, again, solid and open, so it works, right? Solid and open, so it works. Solid, open, and we're good. So it's a function. Okay. All right, so those are your step functions. They just make like staircases. All right, so let's shift gears now. Absolute value. So we did absolute value equations before. So we remember that there's two answers for every absolute value number, right? So let's just use this table here. Okay, so if I graph using this table, plug those numbers in, and let's solve my graph. So -2, absolute value of -2 is +2. Absolute value of -1 is +1. Absolute value of 0 is 0. Absolute value of 1 is 1. And absolute value of 2 is 2. So there's my points. So I can plot these points on here. -2, 2. So -2, +2. There's my point. -1, +1. 0, 0. 1, 1. And 2, 2. And so it makes this graph here into a V. Okay? So a couple things with this V. So we have a special point here at the point of the V. This is called my vertex. Okay, so my vertex of that graph, and you can see here, here's my vertex, and you can see on both sides those numbers repeat themselves. Okay? So we're going to talk about this a little bit more in the next section, but we got parent graphs, parent functions. This is a parent function, okay, of the absolute value. It's just an x. So f of x equals the absolute value of x, okay? Now, we can add a bunch of other things with this, okay? So, as I do this, I can multiply a number in my absolute value, okay? I can subtract inside that absolute value, and I can add inside the absolute value, or I can add or subtract on the outside of that absolute value. So, here's kind of what happens. This a value is a multiplier. It kind of stretches that graph, okay? Or it can compress it based on the number that's being multiplied. Okay? I like to think about it as the slope. Okay? So you can see here, no multiplier. What's my slope? Up 1 over 1, up 1 over 1. And you can see that that slope carries with my graph. Okay? The number inside that absolute value, that's going to move my graph left and right. Okay? Now, whatever the sign is, I'm going the opposite direction. Okay? If it's 0, it's 0. So in that original graph, we don't have any number we're adding inside with my x here. Okay? So that vertex is 0. Right? If I have no number inside and no number adding or subtracting on the outside, vertex stays the same at 0, 0. Okay? The last thing then is this k value. And this k value moves the graph up and down. Okay? So you can graph it with a table. But again, the hard part is you have to have this vertex to graph it with a table correctly. If you don't have the vertex, you may only get a straight line and you won't get the V. Okay? So let's take a look here. We have a couple more. Okay? There's some information here for graphing it in your graphing calculator, so you can do that. Make sure you're getting proper points. Okay? Make sure that those points match up. But now when I'm looking at this, so here, no multiplier, so my slope is 1. Okay? But I have this -5, so this means I'm going to go to the right 5 because it's opposite. Okay? So from my vertex point here, 0, 0, nothing added on the outside, so all I'm going to do is move this point to the right 5. 1, 2, 3, 4, 5. Now there's my new vertex. My slope is still 1. So from that point I can go up 1 over 1, and it kind of goes off my graph. And I can do the same thing or reflect it the other side. So up 1, left 1, up 1, left 1. And I can sketch my graph here. And there's my graph for y equals x minus 5. Okay, so in B now, let's take a look at B, talk about our changes here in B. Now this A value ends up being on the inside. That's okay. That's still going to be that slope, okay? Still multiplying. And my -1 here on the outside, okay? -1 here on the outside is my up or down. So this time I'm using the sign. Same direction as the sign, so I'm going down 5. Or down 1, sorry. So I'm going down 1. Now my multiple of 2, so my slope is now 2 over 1. So again, my original point was 0, 0, right? And I'm going to take that point and move it down 1. So now it's at -1 here on the y-axis. And my slope now is 2, so I go up 2 over 1. It should just be a point, up 2 over 1, up 2 over 1. And there's my new points, and I can do the same thing on the other side, up 2, left 1, up 2, left 1, up 2, left 1. So now I can sketch my V. And there's my graph. Okay? So again, I think this is, if you can remember those, and again, we'll use them down the road. So start remembering those up, down, left, right multipliers. What does it do to the graph? Because it'll make it easier when we graph later on. And I think it makes it easier to be able to do that than to take and plug this in my calculator, plug this into Desmos, and look at it in that sense. Okay? So those are the notes for 2.6. So you can see worksheets down on the bottom right then of your notes. We have one more section in chapter 2.